Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have the 3D isometric projections of a solid, in which this is the front face of the solid, here you have the top face of the solid, and this is the left side face of the solid, and all these three faces of the solid, they are going to present the front, top and the side view projections in a single view, that is a 3D isometric view. Now we are required to convert the isometric projections of the solid into different orthographic projections, and these orthographic projections will be the front view, the top view and the left side views of this particular solid. Now in order to start with the construction of the orthographic projections, we need to evaluate the sizes of the front view, top view and the side view as they will be projected into the orthographic projection. Now while we look at the solid, now the width of the solid in the front view, it is given to us as 80 millimeter. So this is the front view of the solid and this is the 80 millimeter width of the solid. Then the second dimension which will be viewed in the front view will be the height of the solid. So the height of the solid has been provided to us as 50 millimeter. So the front view dimensions will be 80 millimeter by 50 millimeter. Now we move on to the top view. Now in the top view, the two dimensions which are involved, they are the width of the solid, which is again equal to 80 millimeter, and the depth of the solid, it is equal to 40 millimeter, right? So here we have the depth of solid equal to 40 millimeter. So the top view dimensions will be 80 millimeter multiplied by 40 millimeter. Then evaluating the side view dimensions. So in the side view, we are going to observe the depth of the solid and the height of the solid. So the depth of the solid happens to be 40 millimeter and the height of the solid happens to be 50 millimeter. So the dimensions of the side view of the solid will be 40 millimeter by 50 millimeter. Now having evaluated the sizes of the front, top and the side views, now let us evaluate what are the different faces which will be visible to us while we are going to look at the solid from the front view, from the top view and from the left side view. Now when we are looking at the solid from the front view, the faces of the solid which will be visible to us, they are three faces will be there, A, B and C. So the A face, it is an angular face which will be visible to us from the front view. Okay, so this is face number 1, that is face A. Then the second face which will be visible to us from the front view, it is again an angular section or a surface. It is the surface B over here. So surface B has been marked over here into this drawing. Then you have the third surface which is surface C, and it is a rectangular surface. It is lying at the top right corner of this particular solid. So this surface has been named as surface C, right? So we have marked all the surfaces which are going to be viewed in the front view by off-white color, that is A, B and C surfaces. Now let us have a look at those surfaces which are visible from the top. So there are 5 surfaces which will be visible from the top. So in order to distinguish top surfaces from the front surfaces, so we have changed the color to yellow. So surface number 1, it is a square surface. So once again, as usual, we have the bottom block. You can see this will be our bottom block of this construction, and this surface will be the top surface of the leftmost portion of the bottom block, and this is going to measure 40 millimeter by 40 millimeter. Then you have surface number 2, which is the second element over here. So into this surface, we are going to see the dimension of the surface will be, this is 20 millimeter and this is going to be 40 millimeter. So this will be a rectangular surface which is again parallel to the horizontal plane. Then you have surface number 3, which is having dimension. Again, it is a square block. Dimension of the square happens to be 20, right? So it is 20 by 20 square block, and this is a surface number 3. Then you have surface number 4 over here. This is your surface number 4, which is a rectangular surface, and this is surface number 5, which is again a rectangular surface. And all these surfaces, surface 1, surface 2, surface 3, surface 4 and surface 5, all these 5 surfaces, they happen to be parallel to the horizontal plane, and onto the horizontal plane we are going to observe the true shape of all these 5 surfaces in the top view. Similarly, the surfaces A, B and C, which were observed in the front view, these 3 surfaces, they happen to be parallel to the vertical plane. So we are going to observe the true shapes of these 3 surfaces A, B and C in the front view onto the vertical plane. Now let's move on to the left side view. So when we are going to observe the solid from the left hand side, so there will be 3 surfaces which will be visible to us. Surface number 1, this will be surface X. It is a rectangular surface which is corresponding to the bottom block of this particular solid, right? This is the first element. Then there is surface Y, which happens to be an angular surface, and this is available on the second element of this particular block over here, that is surface Y. Then you have the again third element Z. This is again an angular surface which will be observed onto the profile plane. So these 3 surfaces, surface X, surface Y and surface Z, the projections of these 3 surfaces will be obtained onto the profile plane, and since these 3 surfaces, they happen to be parallel to the profile plane, so the projections of the surfaces X, Y and Z, which will be drawn onto the profile plane, they will be revealing the true shapes of these 3 surfaces. So overall, all the surfaces, whether we are going to look at those surfaces from the front side or the top view side or the left view side, all these surfaces will be projected as the true shapes over there, right? So let us move on to the construction of the orthographic projection. So the starting point is you draw the XY reference line and the X1, Y1 reference line. So since we are required to draw the left side view of this solid, so it will be drawn onto the right hand side, right? So here we have front view will be drawn at this position, that is above the XY line. Top view will be drawn over here below the XY line, and the side view will be drawn at this particular position. And this is our transfer line, which is going to be used for transfer of the distances from the top view onto the side view, right? So these are 3 surfaces as we have discussed, that is these surfaces will be visible to us in the front view, and all these 3 surfaces, they are parallel to the vertical plane, so the true shape of these 3 surfaces will be observed in the front view. Similarly, you have these 5 surfaces, 1, 2, 3, 4, 5. So all these surfaces, they happen to be parallel to horizontal plane. So the true shape of surfaces 1, 2, 3, 4, 5 will be observed on the horizontal plane in the top view. Then you have the 3 more surfaces which you are going to view from the side view. So again X, Y, Z surfaces, they are parallel to the profile plane. So the true shapes of these surfaces will be available in the side view, right? So let us start with the construction of the front view. So we know the dimensions of the front view. 80 millimeter is the width, 50 millimeter is the height. So we have drawn the width is equal to 80 millimeter over here. So this is the width of the solid. Let us draw the height of the solid. So height of the solid is given to us as 50 millimeter. So the 50 millimeter height we have projected, and then once we draw this horizontal projector line, so the construction of this rectangular face corresponding to the front view will be completed, and this horizontal line needs to be projected along this horizontal line to the left side view portion. Why? Because the height will also be involved in the left side view. Similarly, this vertical projection line needs to be projected down to the top view, because in the top view also the width of the solid will be required. Now let us plot the top view. In order to plot the top view, you check the width of the solid is available from the front view, then the depth of the solid needs to be drawn over here. So the depth of the solid has been marked as 40 millimeter. So this is our second rectangular face, that is 80 millimeter by 40 millimeter, right? So 80 millimeter by 40 millimeter, it is the top view of this particular solid. Now we are going to transfer the distances of the top view onto the side view. So this transfer line will be used. So through the transfer line, all the horizontal lines, they will be projected vertically towards the left side view. Now here we have been able to obtain the dimensions of the side view corresponding to the solid. So here the dimensions of the side view, they are, that is the depth is mentioned over here as 40 millimeter, and the height of the left side view will be equal to 50 millimeter. Now this height has been represented in the front view, while this depth of the side view, it is represented in the top view, right? So these dimensions from the top view, they have been carried forward and transferred to the left side view. So this is the 40 millimeter depth and this height. So even though we have shown the repetition of these two, you see, dimensions in the side view, but later on we are going to take these dimensions out, because in case of engineering drawing, no redundancy or repetition in the dimension should be there. It is only for the purpose of understanding that we have added the dimensions of the left side view over here. Now let us start with the front view now. So in this solid, so we can check in the front view, this is the first element over here, that is the height over here, it is equal to 20 millimeter. That is the first element on the right hand side. This will be corresponding to the height of 20 millimeter. Then you have the second element B, for which once again the height is equal to 20 millimeter over there. And finally in the third step, you have got the surface C, where the height, it is equal to 10 millimeter, right? So the total height of the solid happens to be 50 millimeter, which is divided into these three surfaces, surface A, B and C. So surface A height, it is equal to 20 millimeter, surface B height, it is also equal to 20 millimeter, while the height of surface C happens to be 10. So this way we are going to now dimension the front view in such a way that these three projection lines we are going to draw corresponding to the top surface of surface A, top surface of the surface B and top surface of the surface C over there, right? So these are three projection lines we have drawn corresponding to top surface of A, B and C respectively. Now next you see here we have got, this is our lower block. Now in the lower block we are going to get this height of the lower block left section over there. This is equal to 10 millimeter. Now we are going to divide this 20 into two parts, that is the lower segment will be equal to 10 millimeter. Then once you reach this point, then we work out that there is another surface over here, surface 3. Now in the case of surface 3, so this is at a height of 20 millimeter above the surface 1 over here. So if we are going to talk about surface 1, it is at a height of 10 millimeter from the base. Then the surface 3 is there. This is again at a height of 20 millimeter above the surface 1 over there. Then you have the final surface, surface 4. So surface 4, it is lying 20 millimeter above the surface 3 over there. So this way all these dimensions, they have been marked in the front view as well as in the left hand side view. Okay, so now let us start with these dimensions over here. So in the top view we can check that the first segment over here, right? And here we have the first segment, that is surface 4, it is going to have the depth equal to 10 millimeter. Then you have surface 5. Surface 5 is having the depth which is equal to 10 millimeter. And finally you have the surface 2, and the surface 2 is having the depth of 20 millimeter over there. Now looking the solid from the top, so we have marked 10 millimeter corresponding to the surface 4. So this is the depth of 10 millimeter. Then again another depth of 10 millimeter is there. This is corresponding to the surface 5. So please check. This is the surface 5 depth 10 millimeter. Then you have surface 2 which is having depth equal to 20 millimeter, right? So the heights we have mentioned over there in the front and left side view. Depth we have mentioned into the top view over here, and then these dimensions they will be transferred onto the left side view. Okay, so whatever you see dimensions they are available in the top view, they will be transferred to the left side view using this transfer line, and whatever dimensions regarding height they are available in the front view, they will all be transferred towards the left hand side view as well. So these will be transferred as horizontal lines, whereas whatever dimensions will be available along the top view, that is along the depth, they will be transferred towards the left side view vertically over there. Now we are left with these dimensions, that is the width dimensions have not been plotted till now. Now we are going to focus upon the width dimension. Now we can check the total width of the solid happens to be 80 millimeter, out of which there is a square block which is appearing as a lower block over there. So it is having the width equal to 40 millimeter. Then there is remaining surface, that is surface A. It is having the width equal to 40 millimeter, and out of this 40 again we have a surface 3 which is extending up to the 20 millimeter width over there, and then these are the two surfaces 4 and 5 which are again extending next 20 millimeter. So we can divide this 80 into 3 segments. The first segment is 20, then the second segment it is again having width of 20, then there is third segment having width of 40 millimeter, right? So 40 plus 20 plus 20, right? So these are 3 segments. You can check that we have divided the solid into 3 parts, that is along the width. Now in the front view as well as in the top view, 2 vertical projector lines I am going to draw over here. So once I draw these 2 vertical lines, it means that I have divided this solid along the width depending upon the different segments of the solids which are available over here. Now we have plotted all the dimensions regarding the height, all the dimensions regarding the depth, and all the dimensions regarding the width of the solid. Now we can join the different segments of this particular solid in the front view. So please check, from the base we have got the horizontal line, then corresponding to this surface, that is surface A left portion. So the left portion of the surface A, it is going to have the height equal to 10 millimeter, and this width will be 40 millimeter. So please check, this width is 40 millimeter, and once you reach this point, now there is a vertical edge equal to 20 millimeter, 10 millimeter for this and 10 millimeter for surface A. So 10 millimeter for the surface A and 10 millimeter for the surface B. So this will be starting from a point, starting from the left, as you move along this surface 40 millimeter ahead over there. So from this corner we have moved 40 millimeter ahead, and then 20 millimeter up we have gone, and then 10 millimeter above as we go. Now we have 40 millimeter edge over here. Please see, this is the width which is equal to 40 millimeter. So this way, so this surface is surface A. So please check, this is going to be my front view projection corresponding to the surface A. Then I am having surface B. So surface B is also angular. Please check, this is having height of 10 millimeter over here. It will be extending 20 millimeter towards the right. again it will be moving 10 millimeter upwards and then 20 millimeter towards the right. So this is also the angular surface. Surface A was also angular surface. Now as I have moved along this, now I can complete the surface B over here. So in order to obtain surface B, please check, move 10 millimeter above, then 20 millimeter towards right, again 10 millimeter above, and then 20 millimeter towards right. So please check, 10 millimeter above, then 20 millimeter towards right, again 10 millimeter above and 20 millimeter towards the right. And finally you have surface C in the front view. So surface C, it is a rectangular surface having a height of 10 millimeter and a width of 20 millimeter over here, right? This is the surface C projection onto the vertical plane in the front view. So once I complete this edge, so this is going to be my surface C. So we must remember that since surface A, surface B and surface C, all these three surfaces which are appearing in the front view onto the vertical plane projections, they are all representing true shape of these surfaces. Since these three surfaces A, B and C, they happen to be parallel to the vertical plane. So A, B and C surfaces, they are representing true shapes of these surfaces of the solid. So this is the construction of the front view. Now let us move on to the top view. In the top view, please check, this boundary will be visible. So I have completed this rectangle of 80 millimeter by 40 millimeter, right? So 80 by 40, so this rectangle has been completed. Then I have got 5 surfaces. So the first surface is corresponding to the lower block, and the lower block was having height of 10 millimeter. So this is my surface number 1. So I will be drawing or darkening this edge, that is at a distance of 40 millimeter from this corner, from the left corner. So this completes my surface number 1. Now I move on to the surface number 2. In the surface number 2, please check, I have got the depth equal to 20 millimeter and the width was equal to 40 millimeter, right? So depth, it is 20 millimeter and the width, it is equal to 40 millimeter. So please check over here, once I draw this line corresponding to this edge of the surface 2, this edge will be represented over here. And what are the dimensions? 20 millimeter, it is the depth, and 40 millimeter, this is the width of the surface number 2. So surface number 1, surface number 2 have been completed. Now I am left with surface number 3. So surface number 3 will be obtained. It is a square of 20 millimeter side. So please check, this is 10 millimeter, this is also 10. And then over here the width is how much? 20. So this is a square of 20 by 20. So if I draw a vertical line over here, then I get surface number 3 over here. And then I have got 2 surfaces, surface 4 and surface 5, which are having the dimensions 10 millimeter by 20 millimeter. So this is also 10 by 20. This is surface number 4. This is also 10 by 20. And this is my surface number 5. So with this construction, I have been able to obtain all the 5 surfaces which are visible to me as I am looking at this solid from above or the top view. Now once again we need to remember, since all these 5 surfaces which have been shown with the demarcation of the yellow numbering over here, right, numbering 1, 2, 3, 4, 5. So all these 5 surfaces, since they happen to be parallel to the horizontal plane, so their projection on the horizontal plane in the top view will be representing the true shapes of all these 5 surfaces. Last, we have got the left side view. So in the left side view, please check, I am looking from the left hand side. I have got 3 surfaces available with me. Surface X, surface Y and surface Z over here. So surface X is having dimensions 10 millimeter by 40 millimeter. This is corresponding to the lower block of the solid over here. So once I darken this edge, please check, through this darkening I have been able to obtain the true shape of the surface X over here. Now next I have got surface Y, which is mounted on top of surface X. Now what is the shape of this surface Y? It is L-shaped surface in which the right side it is having dimension 20 millimeter by 10 millimeter, and the right side it is having dimensions of height is equal to 20, and you have the depth it is also equal to 20. So the total, you see, depth over here has been divided into two parts. So please check. Here I have got the first component, this is 20 millimeter, and then I can get this is 10 plus 10 20. So this way I have obtained the dimensions of the surface Y. I need to draw another line over here. So this is an angular or the L-shaped construction corresponding to the surface number Y, right? So the surface Y, the base is 40. Please check. The base is 40. Towards the right side, that is towards the front side, height happens to be 10, and then the depth happens to be 20. So this is 10 millimeter. This depth is equal to 20. Where I have marked this depth? I have marked this depth over here in the top view. Okay, so this depth has been marked over here as 20. So this is 20, this is 10, and then another 10 upwards, and then as you move back another 20 millimeter. So 10 millimeter up, and then again 20 millimeter back side. So this completes the true shape of the surface Y. And finally I have got the surface Z. In the surface Z, how much is the depth? Depth is equal to 20 millimeter. Out of this 20 millimeter depth, so I have got 10 millimeter upwards, and then 10 millimeter back, again 10 millimeter up, and again 10 millimeter back, right? So it is 10 millimeter up, 10 millimeter back, again 10 millimeter up, and again 10 millimeter back. So this completes the true shape of the surface Z as it appears on the profile plane as we are looking at the solid from the left side view, right? So these are the three surfaces. Now please check. These dimensions I told you earlier, these are there only for your reference, so they are not required later on. So I have removed these dimensions. I have got these surfaces X, Y and Z. So X, Y and Z, they are also true shapes because these surfaces, they happen to be parallel to the profile plane. And another thing we can note over here, the total dimension I had mentioned as 50, whereas the breakup is also mentioned over here 20, 20 and 10. So I can remove some of these dimensions because again if I add all the three dimensions over here and this total is also mentioned, this will lead to redundancy. So that is why one dimension I have eliminated from here and another one also I have eliminated from here. Please check. Total depth was 40. Here I had mentioned 10 plus 10 plus 20 over here. So this was 10, right, corresponding to surface 4. This was also 10 corresponding to surface 5, and this was 20 corresponding to surface 2. But then if I am mentioning three dimensions amounting to 40 millimeter and this total is 40 again, there is going to be repeatability over there. So one dimension I have eliminated out of these three. Now this completes the construction of the orthographic views of the solid. So with this we have been able to complete this discussion regarding the obtaining of front, top and the left side views from the 3D pictorial drawing of this particular component. So I hope that through this discussion you would have been able to develop proper understanding about the procedure to develop the orthographic projections from the 3D pictorial views of the given solids. So we'll be continuing with this discussion in the coming lectures as well. So this is all for today. Thank you very much.